Hello guys, welcome back to Math Zone African Motives. We are still on our mathematics for N6 working on the differential equations. This is August 2023 exam, question number 4. If you had to check, it was 12 marks as usual. So for the first question, determine the particular solution. All right, so there we need the particular solution, not just the general, but the particular solution. Remember, the particular solution, we have to find the general solution, then we substitute the information that we are given. When this is equal to this, we have to use what? That information. All right, so that is 4.1. So 4.1, we are given the tan of theta, dr d theta, plus r is equal to sine squared theta. All right, we're going to take this information later on. If we were to determine the particular solution, this is a first order where we know if it was to be written in terms of y and x, the way that you're given from our formula sheet. I'm going to explain this so that you also understand how you are given here. So this is how you're supposed to be given in terms of y and x. We are supposed to be having this, all right? The derivative of y with respect to x, that is dy dx plus py. But that one is given in terms of r and what? And the theta, dr d theta. So it means y is going to represent r, all right? And theta is going to represent x. Wherever there is x, we're going to write what? Theta. That is the condition, all right? So that is, then we take this part. So I'm going to explain that in terms of what? R and theta, because we are given this in terms of what? In terms of theta. So the format that we are supposed to have here is supposed to be dr d theta plus, here we are supposed to have a function of y, which is p, a function of theta, I mean, which is p times r in this case, all right? Remember, this is r here times r, so it's going to be pr is equal to q. That is the format that you're given from the formula sheet, where p and q, these are supposed to be functions of what? Of theta. They are supposed to carry theta. Okay? If we can have in this format, therefore it follows that instead of having as y, e to the exponent, y is represented by r, remember, so this will be r, e to the exponent, which is our integral factor, the integral of p. Instead of us having with respect to x, we're going to have with respect to what? With respect to theta is equal to the integral of, here we're going to have q e to the integral of p with respect to theta, and your answer is going to be in terms of theta. So therefore, you are going to integrate with respect to what? To theta. So we are writing the same formula that we are given from our formula sheet, but in terms of what? In terms of theta. So we need to have our format this way. That means we to have the r d theta here. What are we supposed? We are supposed to remove this tan theta. So tan is multiplying, so you divide by tan theta throughout. So that means the r d theta is going to be, gonna be a plus, here is r. So we are dividing everything by what? By r, by tan theta. So it's going to be, we want to properly see our p, which represents the function of theta. So it's going to be 1 over tan theta. Remember, we are dividing. It was supposed to be r over tan theta like this. But we want to properly see the term that is representing p and our r separately, so that you properly know that this is your what? This is your p, okay? And this p that we are given, 1 over a tan is what? It's a quart, okay? We're gonna write this one later on. So this is equal to q. We divide by tan everything, so this will be sine squared theta over the tan of theta. We divide by tan everything, so that this here remains as the r d theta. Okay, that's for our linear. So meaning to say here we are going to have the r d theta plus, we said 1 over tan is a what? It's a cot. So this is cot theta. So this is your p, this one. All right, this is your p. So that's r here, that's pr. So that is the p. We are going to need this on the integral of p with respect to, that's why I'm focused about this, all right, which is equal to sine squared theta. Cannot this be simplified? Let's try. Sine squared theta like this, divided to, remember tan, it's sine over cos, it's sine theta over cos theta. So it means we are having sine squared theta over 1 times cos theta over sine theta. Yes, so this can be simplified, all right? Sine and sine cancels. With this one, it becomes sine theta. So this is sine theta, cos theta. So we are going to have sine theta, cos theta. So we can leave it like that, sine theta, cos theta, like as it is, all right? So this is going to give us sine theta, cos theta. Let us just leave it like that. All right, let's just leave it like that. So that is what we are supposed to have in our normal simplification. We have this format now. We're just rewriting in this, in this format here. So it means this is our P and this is our Q, functions of what? Of theta, and this is our R. So on the formula, they state that we are supposed to find the integral factor, which is e to the exponent of the integral of what? Of P. So we are supposed to find this, which is the integral factor, all right? So find the integral factor. We can even find it aside. All right, so here, let us find the integral factor. So our integral factor is going to be given as what? E to the exponent, the integral of P. Take note, the integral of P. Our P is what? Is cot. So is the integral of what? Of cot theta. That is our P. That is our cot theta with respect to theta. So meaning to say we are supposed to integrate cot theta. Is it possible for us to integrate cot theta? That is the question. Is it possible for us to integrate what? A cot. All right. So it's possible for us to have the integral of what? The integral of a cot. So I'm going to take you to the formulas from your formula sheet so that you'll be able to understand. But also remember, guys, your N5 stuff and the reverse of those derivatives and so forth, they help you. But if you do not understand that, I want you to check on your formula sheet on page number 2. It gives you a list of derivatives and integrals. It's only that I did not insert that part, but I want you to check on your formula sheet, all right? You check there on page number 2. We have got the derivative of the integral, because we need the integral there. The integral of a cot, it's written like this: cot AX with respect to X is equal to 1 over A ln sine AX, like this, plus the constant of integration. That is on the bottom end. So it means if we have got cot theta, this is just a 1. So it's 1 over 1, which is just going to be a 1. So it's going to be ln sine AX. Our AX in this case, which is from cot, is cot theta as it is. So it's going to be sine theta. So this one is going to give us like ln sine theta plus what? Plus the constant of integration. So this here, if we were to integrate properly, it was going to give us e to the exponent of ln sine theta. All right, so we do not need the constant of integration. We are still simplifying, remember? So this is what we're supposed to have. But I explained that whenever you have this condition of an e, from our N3, we said e to the exponent of ln x is equal to x. So if this is x, this becomes x. So meaning to say e to the exponent of ln, there is a ln there, it is going to give us this part that is affecting ln, which is what? Which is sine theta. So your answer is going to be direct sine theta without a ln. The ln is not going to be there. The e is not going to be there. Direct sine theta. All right. So we talked about this simplification in our N3, if we still remember. So this is what you're going to have. We have got our integral part, the part of e to the exponent of this. So the formula states that if we can have our integral in this format that we see here, in this format, therefore, we are going to have this formula. It's a continuation from there. Therefore, so you're going to have R in this case. So this will be R times e to the exponent of this e. What does it represent, this e? It is that integral factor, this one. That is our integral factor. And we simplified this up to where we got what? A sine theta, direct sine theta. So this one, it is going to be R sine theta. All right? Is equal to, so we're going to have equal to the integral of Q. What is Q? Q is what we have on the right-hand side from our format of this equation here. So this is our Q, which is sine theta cos theta. That is your Q times what? The integral, again, e to the exponent of that integral. And what is it? Here we got sine theta. So we're going to multiply by sine of theta like this with respect to theta. That is what we are having there. That is what we are having there. So what are we going to have at the end? All right, let's see. From what we have, we are supposed to integrate this. So how do we integrate? R sine of theta is equal to, as we can see, we are having sine and the sine, so we multiply sine times sine is going to give us sine squared theta cos theta with respect to theta, of which there we can use substitution method. Yes, we can use those identities, but here, guys, we can just use substitution method. So we're just going to integrate this aside. If we take back our N5 mathematics, we can see this part, we talked about this. So the integral of a sine squared theta, this is the integral of sine squared theta cos theta with respect to theta. So you can use substitution there by letting you can, if we let you sine can cancel this cos. So it's possible for it to cancel if u is equal to the sine of theta, the complicated part. So you're going to have du d theta, which is cos theta. All right. So make d theta the subject. So you're going to make d theta the subject, which is going to be du over the cosine of theta. So if we substitute this, that will be the integral of sine squared, which is u squared times the cos of theta will cancel with this. That is on d, because we are going to substitute. Remember, you are going to substitute this d theta here on this one. So this cos theta and this will cancel. All right. So you're going to be just left with what? Du like that. So you integrate this, which is going to be u to the exponent of 3 over 3 plus that constant of integration, whereby our u, remember, is what? Is the sine of theta. So that was going to give us the sine cubed of theta over 3 plus c. All right. So this is what you're going to have, r sine of theta. So you're going to have r sine of theta is equal to the integral of this part. After integrating, we obtained what? Sine cubed theta. So this is sine cubed theta over 3 plus the constant of integration. We've integrated the whole of this part. This is what we did here on this substitution method part. All right. So with this information that we have, what we just obtained now is what we refer to as the general solution. This is our general solution. But the question is not about the general solution. The question is asking us to determine the particular. When we have the constant like this, we have what we call the general solution. So what are we going to do now to determine the particular solution? We need now the information that we are given here, where we are given that we are supposed to determine the particular solution if theta is what? Pi over 6 and r is 3. So theta is pi over 6, r is equal to 3. So r is equal to 3 and theta is pi over 6. So theta is equal to, sorry for that, pi over 6. So the pi over 6 means your calculations are in radians. All right, you calculate in radians when it is like that. So this is what it means. So r here is going to be 3 sine of theta, which is sine pi over 6 here. All right, then we are going to subtract, because we want to find c, remember. So you're going to take this to the other side. We subtract this to the other side. And on the calculator, this is how you simplify sine cubed. You write it as sine theta. So it is going to be sine pi over 6 like this. Then you raise everything, the sine of it, to the exponent of 3. That's how you simplify it on your calculator. But this pi over c, we know that automatically your calculator opens a bracket, that one. So it's going to be in a bracket. So this is equal to what? This is equal to c. So we just made c the subject, transpose this so that we just simplify at once. Than to say we simplify this, then we combine. Yes, it's fine, we can do that. All right, so like I said, the moment we work with this pi it means your calculator must be in radians. So you're going to change your calculator to radians. Already my calculator here is, if you see here, there's R here to show that it's in radians, right? It's in radians. So this is going to be 3 sine pi over 6, all right? So this is pi over 6 like this, all right? So you're gonna close the bracket, minus, all right? So let's just save a fraction again. So open a bracket for this sign, all right? Before that, I just need a fraction first like this. Then I open a bracket on the numerator there. So I'm gonna open a bracket for sine pi over 6. So this is pi over 6 like this. All right, close this. This is the bracket that is automatically opened by the calculator. So just close it aside like this. Then we have to square ours, this one. We have to raise it to the exponent of 3. So we have to close this. Then we raise to the exponent of 3. That is to show that we have affected the whole of this sign here. The whole of it is being affected. All right, so everything is over what? Over 3. Okay, so that's what we have. So this is going to give us 35 over 24. So C is going to be 35 over 24. So 35 over 24 is equal to C. So after finding C, now we have got the particular solution by substituting the value of C. Before it was the general solution here. Now we substitute our C, the one that we got. So therefore, R sine of theta is going to be equal to what? Everything remains as it is. So that's sine cubed theta over 3 plus C. Our C in this case is 35 over 24. So this is going to be 35 over 24. So that's it. We are done. So that is now the particular solution. We have particular solution now. All right, solution like that. So I just hope, guys, you revise more on different questions, because there is a different approach that you see in each question, but it's just one and the same thing. Like you are simply following one and the same thing. The formula is still one and the same, only that sometimes you're working with a trig, you're working with the normal algebraic, you're working maybe with an exponential. You don't know what you're working, but the format and the layout is the same. That is how you work out this one. All right, then the second part, it was still on the determining the particular solution, this time 7 marks, and this is a second order. So we're given the particular solution again, whereby the second derivative of y with respect to x minus dy dx, all right, minus 2y in this case is equal to 1 minus 2x. All right, where that is because we need to find what? The particular. So we said for second order, what we just need, guys, this one is a direct, as you can see, this one is a little bit direct from the other questions that we have answered before. Because here, remember the format that we need is to have our auxiliary, you need the auxiliary equation, but that is supposed to be from the format of A, second derivative of y with respect to x plus b dy dx, all right, plus cy is equal to f of x. So to find our auxiliary equation, we let our dy dx to be equal to r. So you can let r, you can let m, I talked about that, all right? So you're gonna let r to be equal to dy dx, and y at that moment will be equal to 1, whereas the function of x will be equal to 0. So if we take this into consideration, we formulate what we call the auxiliary equation. So if this r is representing dy dx, this one is a second derivative, so it means we've got r squared minus r in this case minus 2 times y. Y is 1, so if you multiply by 1, it's just going to be minus 2. And this will be equal to what? This will be equal to 0, because we said the whole of f of x is now represented by what? By a 0. So with this auxiliary equation that we have, we are going to solve so that we obtain what we call the complementary function. that is from the other values, checking whether they're the same or not. So this is a quadratic, but I think factorization can work there. Let us just have two brackets is equal to 0. So since the coefficient of r squared is 1, we're going to have r and r here. Factors of -2, but we add up to give us a -1. That's -2 and a 1. If we multiply this, we get -2. If we add this, we get a -1. So these are the factors, -2 and +1. Okay, so that means r will be equal to 2 or r will be equal to -1 on the other side. Okay, so these are the solutions that you're obtaining. These solutions, they are different. So you go back to the formula sheet on these formulas, they presented for you everything that you need in terms of the solutions. All right, we are talking about on a condition where on these solutions here on this part. All right, so it gives us a condition when these solutions are the same or if they are not. On that condition, they are not the same. We take this condition, R1 is not equal to R2. So we are going to use this simplification to write our complementary function. If R1 and R2 were equal, you're going to use this one. If R is going to give us the solution from a complex solution, whereby we're talking about a complex number, you're going to expand using this. You're going to use it as your YC, which is the complementary. But this one, they are different. We have got two values that are different for the R that we got. That is why we are saying R1 is not equal to R2. The solutions that we got here is 2. The other one is -1. So we saw that on that part, if our solutions are different, it follows that Y is going to be given as, all right, Y is going to be given as, that is our complementary. So we're going to write this as YC. All right, it is e to the exponent of R1x plus b e to the exponent of R2x, whereby these are R1 and R2, R1 and R2. They are different. Our solutions are not the same. R1 is not equal to R2. So that's, we have to use this on our complementary. So that's YC is equal to A, e to the exponent of R1, which is the first solution, which is 2. So it's going to be 2x plus b, our constant again, e to the exponent of R2, which is -1. So this will be -x. We are done. So on the complementary part, don't worry for anything at that stage. Just leave it like that. At that stage, you're done. You will leave it like that. There's nothing that we're gonna take or that we need more from this complementary. We'll see the last stage. We'll see that one on the last stage, when now we are to determine the value of A and B, because they need us to find the particular solution. So we have to find the value of A and B for the particular solution. But for now, like what I said here, you leave this as it is, your complementary function. This one, just leave it as it is. So what you're going to do, you move on, because we need a combination that is going to combine these two, the complementary and the particular. Y is supposed to be the complementary plus the particular integral. So where are we going to have YP? YP, we are going to take it from the original derivative that we are given here. From this function, we can check and see that in order for us to have YP, we can see that this here is a linear on this side. We are working with a linear, all right, sorry, I want to have this. We are working with a linear expression, the format of mx plus c, that's a linear. So it means, therefore, YP, which is the complement, which is the for the particular integral in this case, all right, for the particular integral, this is what we are going to have. So YP is going to be taken from the linear expression. We take it as a linear equation. Since we are supposed to have mx plus c, we are supposed to use these letters A, B as constants. So we have already used A and B. So we are going to continue from this using C. So it is going to be Cx plus what? Plus D. We are supposed to have the format of a linear, a straight line. So it means Y is equal to Cx plus D. Where are we going to use this Y? Because we need to find C and D. We are going to use it back to the original equation. In place of Y, we have to substitute this Y. But if we substitute Y here, what are we supposed to do? We are also supposed to substitute dy dx. We are also supposed to substitute what? The second derivative of Y with respect to X. So it means from this YP, we are supposed to also find its derivative of y with respect to x. All right. So if we differentiate this c, x is going to be c is a constant, then d is a constant, gives us a 0. Also, like I said, we are going to need the second derivative. The moment we substitute the y here, we cannot just substitute that without having dy dx. Without having, we cannot. So that's why I'm saying we need this. And this gives us a 0. Now we can substitute so that we find c and d. So how do we substitute as it is here? So let us just try to separate this. All right. So as it is from the equation here, we're going to substitute as it is. This is the second derivative, which is 0 in this case. So that's 0 minus dy dx. So that's minus dy dx. What is our dy dx? Our dy dx is what? It's c. So it's minus c minus 2y, which is minus 2 times y. What is y? Y is equal to cx plus what? Cx plus d. So it's minus 2 times cx plus what? Cx plus d, like this. So this is going to give us what we have as the linear on the other side of the, we substituted on the left-hand side, but it gives us exactly what we have on the right-hand side, which is 1 minus 2x. So this is equal to 1 minus 2x. We have formed an equation where we can solve for c and d because these two are equal from both sides. So we are going to equate them from the coefficients, all right? That's a 0 here. It's going to remain with minus c. Minus 2 times cx is going to be minus 2cx. Minus 2 times d, that will be minus 2d is equal to 1 minus 2x. So if we work with the coefficients of x in this case, if we are working with the coefficient of x, on the left-hand side, we've got x here. So you equate the coefficients, all right? So we're going to equate the coefficient of x here. Here we've got x, we equate the coefficient of x. On the left-hand side, minus 2c must be equal to the coefficient of x on the right-hand side so that you can be able to calculate the value of c. If we divide by -2 by -2 here, c is going to be a 1. All right, you do the same thing from the constants. All right, working with the constants, you are going to equate the constants in this case. What we have here, we've got minus c minus 2d. All right, minus c minus, these are constants. It must be equal to the constant on the other side, which is what? Which is 1. But we have the value of c, which is what? A 1. So c, it's minus 1. So this is minus 1. We transpose minus 1 to the other side, it becomes what? A positive. So minus 2d, it's 1 plus 1, which is 2 divided by 2. So d is going to be -1. So we have the value of d, we have the value of c from the particular integral. We took this from our particular integral, c and d. Yp is supposed to be cx plus d. So this is what we are going to have. So therefore, this yp here is going to be given as cx plus d from cx plus d that we have. This is going to be c, which is 1. So it's going to be x minus d, which is x minus 1. So this is our particular integral. Not to say this is the solution of our question. No, this is not the solution. We are supposed to have the combination, like I said, after you've determined this, after you've worked out your particular integral from that y that you took from what you have on the right-hand side. You work with the type of, is it quadratic? Is it linear? All right. So we talked of a quadratic. This is for a linear. I think we're going to need a question for an exponential so that we'll be done with everything now. All right. So this is what we say. We're going to combine yc and yp together so that now we have the value for what? The value for y. All right. So let us combine and see what we are going to have at the end. All right. So remember, we've got yp here. So therefore, y is equal to yc. This is our yc here, which is a e to the exponent of 2x. All right, plus b e to the exponent of minus x. So we've got our complementary. Then we add yp from our particular integral there. We got x minus 1 in simplified manner. This is x minus 1. It's already in a simplified manner. All right, so this is what we're going to ask our questions ourselves now to say. How are we going to find the value of A and B? Because this part that we see is called the general solution. This is our general solution now. All right. So there we have got the general solution. If we have got A and B, these ones as our constants. So in order for you to have the particular, you must substitute whatever that you have to find the value of A and B. So that's where we go back to the information that we are given about this whole differential equation, that y is equal to what? Y is equal to 0 when x is equal to 0. And also the derivative of y with respect to x is 1 when x is 0. So you have to use this information now. All right, so this is where we go now on that information, on that equation that we have for y, this one. We are now having this, a combination. When we after combining the complementary function and the part of the particular integral, after combining those two, that's where you think of finding A and B. That's the last step to do. All right, so we are given where y is equal to 0. That's the first condition, when x is equal to 0. All right, and another condition is the derivative of y with respect to x must be equal to 1. At that moment, x must be equal to 0. All right, so let's use the first condition. So the first condition is direct. Y is equal to 0. It means wherever there's y, I'm going to substitute as 0. So 0 is equal to, wherever there's x, I'm going to put a 0. So this one, it's a 0 here. So e to the exponent of a 0, that's a 1. So 1 times a, that's a. E to the exponent of a 0, that's 1. 1 times b, that's a b. All right, in place of x, you substitute a 0 here. So that's 0 minus 1, which is minus 1. All right, so that's it. We have formed an equation. You can even take 1 to the other side, so that will be 1 is equal to a plus what? A plus b. Okay, just leave it like that. Let's say it's an equation, our first equation. There are two unknown values there, so there's nothing that we can do. We can't find A, we can't find B. So just leave it like that. We move on to the second condition. The second condition is where we are applying the derivative, I mean. They gave us the derivative of y with respect to x. So there's no way, we have to find this derivative of y with respect to x. So we are going to find the derivative of y with respect to x, which is here we differentiate e. Remember, drop these two to multiply x, the derivative of e. We find the derivative of f of x, multiply it to the constant a. So it is going to be 2a e to the exponent of 2x. The same thing, the derivative of minus x is minus 1, so it's minus b. So it's going to be minus b e to the exponent of minus x. The derivative of x with respect to x is what? It's a 1. The derivative of minus 1 is a 0. So this is our dy dx. So they are saying dy dx is 1 at a condition where x is equal to 0. So if x is equal to 0 here, remember e to the exponent of 0 is 1. 1 times 2a, this will be 2a. E to the exponent of a 0 is 1 times minus b, so this will be minus b plus a 1 here. Okay, so we can transpose this 1 to the other side. That will be 1 minus 1, which is a 0. So 0 is equal to 2a minus b. So we are now having another equation again here. So this is our second equation. So we've got another equation here. So we have the first equation, this one. All right, so it's gonna have as our first equation, and this is our second equation. So to solve here, guys, it's up to you. How are you going to solve it? It's either you're going to use elimination, substitution, but what is important is that you can properly see your equations that you are supposed to solve. The first one, a plus b, which is equal to 1, 2a minus b, which is equal. These are the two equations that you're supposed to solve. All right, so as for me, I was just gonna take this, make b the subject here, because I have b also, I can make b the subject here. So from this one, I can make b the subject. That will be 1 minus a is equal to b. I can also make b the subject on this equation, transpose it to the other side here, it becomes a positive b. So it means b is equal to 2a. So there's no way that these two b's are the same. B is equal to 2a here. B here is equal to 1 minus a. So what does it mean? It means this 1 minus a and this 2a must be equal. So it's an equation that you're going to formulate. 1 minus a must be equal to what? Must be equal to 2a. All right, so we can solve for a from that one. All right, so that's 1 is equal to a minus a to that side, it becomes a positive. So it's 2 plus 1, which is 3. So that will be 3a divided by 3 by 3, both sides. So a is going to be 1 over 3. So to find b, we can substitute anyway. We can substitute here. We can substitute here anyway. But I can just take advantage of this because I'm saying b is equal to 2a. So b is equal to 2 times a, which is 1 over 3. So b is going to be 2 times 1 over 3, which is 2 over 3, just like that, okay? So I now have the value of a and b. It means I can now have the particular solution. That's, guys, you have to be very careful to answer the questions correctly and properly. So therefore, y is equal to a e to the exponent of 2x. So therefore, y is equal to, remember it was a, which is 1 over 3, e to the exponent of what? It was e to the exponent of 2x. Then we move on. We also have b. This is b, e to the exponent of minus x. So this is b, which is 2 over 3, b 2 over 3, e to the exponent of minus x. Then we have got the rest of that linear part that we got from our YP, from our particular, which is x minus 1. Just going to substitute as it is. So that's plus x minus 1 plus x minus 1, like this. All right, so this is what we are going to have at the end, plus x minus 1. So this is the whole part that we are going to have representing y. So we now have what we call the particular solution. The first one here was the general solution. Here we had the general solution from the first part here, this one. When we have got a and b, the a and b is still there. We still have a and b. We have the general solution. When we have solved for that a and b from the information that you are given, you have solved for a and b, you now have what you call what? The particular solution. So this is your particular solution. All right, so we just hope for more questions to come. And also, let's revise as much as we can. Also, as an individual, try to do more question papers just to figure out how do they ask these questions and how are you supposed to attempt them. So those are the examples of how your differential equations might be given as. So this was August 2023 exam. Like I said, as you can see, it was a little bit fine. You can say it, I can't say it's easy, but it was just fine, right? It was just normal. I don't know what you think about this person, but from the look of things, I see as if it was fair enough, yeah, with the marks, and also it was fair enough. We shall see more questions in our review.